So today we're going to be talking about domain and range and function notation. And so we already talked about the three different parts of a function, but you're going to be able to identify what the domain and the range is, and then you're going to use something called function notation in order to evaluate expressions. So let's go ahead and get started with an example. Function notation is how we write the rule of a function. So you know how we've written equations before where it's y equals maybe like 5x plus 2. Well, the input is the x values and the output is the y values. But in function notation, we express the y as f of x. In other words, it's a function in terms of x, where the rule is you take x, you multiply it times 5, and you add 2. And the reason we do that is because whenever we want to find a specific value, like let's say we want to find f of 2, what we're going to do is just replace the x with a 2. And so it'll be 5 times 2 plus 2. And then 5 times 2 is 10, 10 plus 2 is 12. And so f of 2 is equal to 12. So let's take a look at this example. In example number 1, we have a function rule in a function notation, which is f of x, where we have the rule is 3 times x plus 2. If we want to find f of 5, we're simply going to replace the 3 with the x with a 5. So it's going to be 3 times 5 plus 2. 3 times 5 is 15. 15 plus 2 is 17. And so we know that f of 5 is 17. So try f of negative 3. Use the same function, but plug in negative 3. You might want to pause the video, try it on your own, and then restart the video and I'll go through it with you. So f of 3 is really the same thing as f of 5. We're going to replace the x, though, instead of with a 5, with a negative 3. And I always put parentheses around it. So here we have 3 times negative 3, which is negative 9. And negative 9 plus 2 is negative 7. So f of negative 3 is negative 7. Let's move on here. Try our example number 2. So here we have a different rule, g of x. So this is a g function in terms of x. And we want to find g of 3. So g of 3 is simply going to be not x squared, but 3 squared plus 5. We know that 3 squared is 9, and 9 plus 5 is 14. So g of 3 is 14. So 3 is the input, and 14 is the output. Try g of negative 4 on your own. Hopefully you tried g of negative 4, and hopefully this is what you came up with. G of negative 4 is equal to not x squared, but negative 4 squared plus 5. So we're just going to take negative 4 and square it. That's negative 4 times negative 4, which is positive 16, because it's a negative times a negative, plus 5. And 16 plus 5 is 21. So g of negative 4 is 21. Let's try some different examples here. Here we're getting a little bit more difficult. Here we have h of x. It's an h of x function, but we have 2 x's. That just means we're going to plug the input in twice. So when we have h of 5, then h of 5 is going to look like this. Whenever I see an x, I'm going to replace it with a 5. So we're going to have 2 times x squared, but x is now 5 squared, plus 4 times 5 minus 8. And so if I follow the order of operations, I'm going to do my exponents first. 5 squared here is 25, so it's 2 times 25. Plus 4 times 5 minus 8. So 2 times 25 is 50. Plus 4 times, that's a 5, is 20 minus 8. 50 plus 20 is 70. And 70 minus 8 is 62. And so h of 5 is 62. So let's try h of negative 3. Try it on your own and then start the video and see if you get the correct answer. So hopefully you did that. And h of negative 3, I'm going to do it up here. H of negative 3 is simply going to be 2 times negative 3 squared plus 4 times negative 3 minus 8. So we're going to do the parentheses or the exponents first. So here we have 2 times negative 3 squared. Well, negative 3 squared is positive 9 because it's a negative times a negative. So we have 2 times 9 plus 4 times negative 3 minus 8. 2 times 9 is 18. Then 4 times negative 3 is negative 12 minus 8. And 18 minus 12 is 6. And then 6 minus 8 is negative 2. So h of negative 3 is negative 2. Okay, we keep trying different functions. All of them are different rules, and each one just adds something a little bit difficult. Here we still have two x's, but we have x's on the top and the bottom. And so let me do f of 4 with you, and you could do this in your notes. So we have f of 4, and again, all that means is we're going to replace every x with a 4. So it's going to be 4 squared plus 6 all over x, which is 4. So if we follow the order of operations, we're going to take 4 squared first. Well, 4 squared is 16 plus 6 over 4. And I still have to do what's on the top first. There's like an understood parentheses around the numerator. 16 plus 6, well, that's 22 over 4. And 22 divided by 4, well, 4 goes into 22 5 times. And 5 times 4 is 20, so that's, we could write that as 20 and 2 out of 4 left over, but 2 out of 4 is the same thing as a half. So f of 4 is 5.5. Or you could say it's 5.5. If you took 22 divided by 4, you would simply get 5.5, which is the same thing as 5.5. So I want you to try f of negative 3 on your own, and then restart the video and see if you have that correct. So hopefully you've done that. F of negative 3 is simply going to be negative 3 squared, because we're replacing this x with negative 3, plus 6 divided by negative 3. And negative 3 squared, well, that's 9 plus 6 divided by negative 3. 9 plus 6 is 15 divided by negative 3. And 15 divided by negative 3, well, that's negative 5. So if we stick negative 3 into the function, we're going to get negative 5 back out. And that is what f of negative 3 is. So the input is negative 3, the output is negative 5. All right, let's go on with a different example here. So here, what messes a lot of people up on an example like this is the fact that we have this negative here. So let's try first the f. These should match. This is probably be an f of 4. So if we want to find f of 4, I am going to have f of 4, and I'm going to replace every x with a 4. So it's going to be negative and then 4 squared plus 3 times 4 minus 4. And so we have negative, but 4 squared is 16. And so notice this is different. This is going to be negative 16 here. Because I square it first and then I make it negative. Plus 3 times 4, that's 12, minus 4. So negative 16 plus 12, well, that's negative 4, minus 4, and that's negative 8. So f of 4 is negative 8. If I try negative 3, you could pause it and then try it with me. That would be ideal here. So f of negative 3 is simply going to be negative. And then I have the x, which is negative 3 squared, plus 3 times negative 3 minus 4. So here we have negative, but then negative 3 squared, that's a negative 3 times negative 3, which is 9. Plus 3 times negative 3 is actually negative 9 minus 4. Negative 9 minus 9, that's the same thing as negative 9 plus a negative 9, which is negative 18, minus 4. And that's negative 18 plus a negative 4, which is negative 22. So it's really important that we know our positive and negatives during this unit, because they're going to come into play quite a bit. Negative 18 minus 4 is the same thing as negative 18 plus a negative 4. You have 18 bad guys, and 4 more bad guys is 22 bad guys. All right, so let's take a look at these examples here. So we have two functions here. f of x is 2x plus 1. G of x is x squared plus 2x plus 1. And number 6, we are going to find f of 5 plus g of 2. So f of 5 is simply going to be this expression, but it's not going to be 2 times x. It's going to be 2 times 5 plus 1. Plus, I'm going to take that, plus g of 2. Well, g of 2 is going to be this function, but instead of x squared, it's going to be 2 squared plus 2 times 2 plus 1. So we have this entire expression. This is f of 5 and over here, and this here is g of 2. So f of 5, 2 times 5 is 10, plus 1, this is 11, plus over here we've got 2 squared, which is 4, plus 2 times 2 is another 4, plus 1. So we have 11 plus 4 plus 4 plus 1. Well, 11 plus 4 is 15, plus 4 is 19, plus 1, that is 20. So let's try 7. We're going to take f of 3 first. Let's just do this one step at a time. If I take f of 3, it's not going to be 2 times x. I'm using this function here. It's not going to be 2 times x. It's going to be 2 times 3 plus 1. Well, 2 times 3 is 6, and 6 plus 1 is 7. But it's 2 times that. So I'm going to take this whole thing times 2. That's where this 2 comes in. And 2 times f of 3 is 7, so 2 times that is going to be 14. So this part right here is 14. But then we're going to subtract g of negative 2. So g of negative 2 is going to be negative 2 in parentheses squared. Again, I'm using this right here. Negative 2 squared plus 2 times negative 2 plus 1. That's a 1 there. So negative 2 squared is negative 2 times negative 2, which is positive 4. And then plus 2 times negative 2 is minus 4 and minus 1. 4 minus 4 is 0, and 0 minus 1 is negative 1. So this whole thing here is negative 1. And what we're going to have is 14 minus negative 1. Well, that's the same thing as 14 plus a positive 1, which is 15. So you can kind of see how we're using function notation throughout this. Let's try another example. So find the range values for the given domain values. So here we have 3 domain values. So the first thing that we're going to do is plug in the first domain value, which is 3. And if I plug in 3 for the x, I'm going to have 5 times 3 minus 3. Well, 5 times 3 is 15, and 15 minus 3 is 12. So the first one's 12. Then I'm going to plug 5 in. It's going to be 5 times 5 minus 3. Well, that's 25 minus 3, which is 22. Then I'm going to plug in 8. Well, that's 5 times 8 minus 3. 5 times 8 is 40, and 40 minus 3 is 37. And so the range values are going to be 12, 22, and 37 for these given domain values. All right, let's try the same thing with this example here. If I plug in 3 first, I'm going to have 3 squared. Well, let me just try to do some of this in our head here. 3 squared, that's 9, plus 2 times 3 is 6, plus 4, over 3 minus 2, which is 1. Well, 9 plus 6 is 15, plus 4, that's 19 over 1, which is 19. So there's the first range value. Then I'm going to plug in negative 4. Negative 4 squared is 16, plus 2 times negative 4 is negative 8, plus 4. And the bottom, negative 4 minus 2 is negative 6. So in the numerator, 16 minus 8 is 8. 8 plus 4 is 12. Divided by negative 6 is negative 2. And then if I do the same thing with positive 6, 6 squared, I'm doing this one first. 6 squared is 36, plus 2 times 6, well, that's 12, plus 4. That's the numerator. Then 6 minus 2 in the denominator, that's 4. 36 plus 12 is 48, plus 4, that's 52. And 52 divided by 4 is 13. Hopefully this helps, and we will talk more about this in class tomorrow.